Okay, so far we have done solving systems by graphing and solving systems by substitution. This is our last method, which is the elimination method. Now, the other methods definitely have their pros and certain circumstances that they work really well in. Okay, the elimination method is the most common method, I think. Okay, because you can use it, okay, for any of the situations. And you're going to find that even if it doesn't look like we can use it, we're actually allowed to kind of manipulate our equations to make it work for us. So I say this is probably the most common. And if I have a choice, I usually use this one instead of the other ones. And it is important to note that when you are doing this, both equations should be in the same form. Okay, I usually make them in standard form if they're not already. Technically, you don't have to have them in standard form to do this, but it kind of just makes more sense to me when they're in standard form. Just looks a little bit better. Okay, so what is going on here? So we're going to have four examples, and they're going to start off easier and then get a little bit harder as we go. Okay. Example one, either the x's or the y's have coefficients that are opposites. Okay, so now keep in mind the title of this is the elimination method, meaning something's got to go. So we need to do something to our system that's going to eliminate something. And I'm not sure if you're looking at it and seeing it. Some people don't jump to this conclusion because it's kind of weird to think of if you don't really know what to do in that case. But in this case, because our x's are 2x and negative 2x, and they are opposites, what we are actually allowed to do, okay, is add our two equations together. And the reason this works is because 2x plus negative 2x is 0. They are eliminated, and then we will only have the y's left. Okay, so in this case, when coefficients are direct opposites, we are just going to say add the equations. Okay, so when we add the equations, like we said, the x's add to 0, so they're gone. We get 8y equals 24. And now I can solve that and say that y is 3. And that's one piece of it. Now we have to plug in the number. I'm going to abbreviate here. Plug in the number into either equation. It will not matter which one. I tend to look at what has smaller numbers or what has less negatives, but it really doesn't matter. Okay, so we're going to plug them into the other equation. So I'm going to use the first one. So we have 2x plus 3y equals 11. We just solved and said that y equals 3. So we're going to plug in y is 3. And then we solve. So that's 2x plus 9 equals 11. Subtract the 9 from both sides. 2x equals 2. And divide by the 2, x equals 1. So our final answer, remember x comma y in an ordered pair form, will be 1 comma 3. And as always, at least mentally plug in that 1 comma 3 in for the x and the y in both of your equations and check to make sure it works. Okay, because you should have a pretty good understanding if it's correct or not by plugging in your answer. Okay, so that's the first one. When something is the opposites, just add your two equations. Okay, the next one, example 2, either the x's or y's have coefficients that are the same. Now, I'm going to give you two different methods on this one. I'm going to show you one way, but I'm going to be honest and tell you I like the second way better. That's my opinion. Okay, choose what you want to do, but I will say with the first way, be careful of your integer rules. Things can get a little tricky. So here, if we are trying to eliminate something and the y's in this case are the same, we have 3y and 3y, okay, we could subtract our two equations. Okay, so I'm going to say if the coefficients are the same, we can subtract. Because 3y minus 3y is 0, we can cross it off. 4x minus 5x is negative x. And then this is where we have to be careful, like I said. It is 2 minus negative 2, which means that is a positive 4. Okay, and if negative x equals 4, that means x equals negative 4. Your other option, okay, or, okay, like I said, we can kind of manipulate things to do what we want. Okay, we can, oops, sorry, we can change the signs of one equation, which will make it just like the question before, where we'll have opposites. So we'll say, and then we can add. Okay, so what I mean by that is if we happen to take the first one, we could do either one, doesn't matter. But if I took my first one, I would turn it into negative 4x minus 3y equals negative 2. We would then have 5x plus 3y equals negative 2. And now because my negative 3y and positive 3y are opposites, we can add them together. I like that way better. Like I said, it is your choice though. Okay. But I find that dealing with adding things together, I like that better than trying to subtract. Okay. But we're not done yet. So once you got here, it would end up being exactly the same as that over there. Actually, it'll just get you x equals 94, but same idea. So now we need to figure out what the y is going to be. So we are going to plug in to either equation. I like the first one again, so I'm going to say 4x plus 3y equals 2, and we're plugging in x of negative 4. That gives us negative 16 plus 3y equals 2. Add the 16 to both sides. 3y equals 18, and then y equals 6. And final answer for this one, x is negative 4, y is 6. Negative 4, 6 is our answer. Okay, so once again, when the signs are the same, you can subtract your equations, but be careful. Okay, or you can switch all the signs of one equation and then add them together because you'll have opposites in that case. Okay, example 3. Neither the x's or y's even have the same number as the coefficient. Okay, look, we got 6x and 2x, 5y, 3y. Nothing matches. Okay, but this is where I said it always works with this method because we can manipulate things. And what's nice is in this particular case, if I'm focusing on the x's, 2 goes into 6. So in this case, I only have to manipulate one of my equations to make it do what I want it to do. So what I'm going to do is I'm going to multiply my second equation. Some of you might be thinking to do 3, and 3 would be perfectly fine. But you would have 6x and 6x, and then you would have to make sure you're subtracting your equations. I mentioned that I really love adding. So for the purpose of this, I'm going to say, let's throw in a negative as well. It's going to be your choice, okay? And I will not tell you to do one way versus the other, okay? But I can just keep recommending, okay, because I've seen this over the years, that adding your equations together is easier than trying to subtract things at times. Okay, so I'm going to throw in the negative so that I can add. So my first equation stays the same. My second equation, remember, I have to do it to every single piece. So it's going to become negative 6x minus 9y equals negative 15. Now I can add my two equations together because 6x plus negative 6x is 0. We end up with negative 4y equals 4 and y equals negative 1. And then from there, we got to plug it in. I like the second equation better in this case because smaller numbers. So I'm going to say 2x plus 3y equals 5. We're plugging in y of negative 1. So 3 times negative 1 equals 5. That becomes 2x minus 3 equals 5. We add the 3. 2x equals 8. Divide by 2, x equals 4. And final answer, x is 4, y is negative 1. Okay, so I'm going to add up here because I did not do that yet. For this one, okay, when one of the numbers goes into the other one, you can multiply one equation to make x's or y's match. Or opposites. I like opposites more. Okay, last one. Example 4. Neither the x's nor the y's have the same number as a coefficient, and neither coefficient goes into the other. Okay, for this one, focus on the x's or y's. Pick one, doesn't matter. Okay, and multiply both equations to make them match. I'll just say multiply both equations. I think you get the point of this one. Okay, so, okay, I'm looking at this. I have 4x and negative 3x, 5y, and 2y. I think I'm going to focus on the x's because they're already opposites. Not opposites, but they're different signs. Okay, which means when I multiply them, they will be opposites. So I'm going to say, let's turn this one multiply by 3 and this one multiply by 4. Okay. You're always saying, like, what's the least common multiple of them? Okay. Sometimes it might just be multiplied by the other number. Sometimes, if you want the smallest numbers, it could be something different than that. Okay, but 3 and 4 will work here. So my first equation becomes 12x plus 15y equals 105. The second one becomes negative 12x plus 8y equals negative 36. Okay, when I multiply them together, sorry, when I add them together, because I have opposites here, I would add, okay, we have our x's eliminated. We get 23y, 69 there, y equals 3. Now I'm going to plug it in. I like the smaller numbers on the bottom one, even though there's negatives. So I'll say negative 3x plus 2y equals negative 9. We're plugging in y of 3. So that gives us a plus 6 there. We would then subtract it to get negative 15. And x would be positive 5. So final answer, 5, 3. Okay, so that is elimination. So once again, if your x's or y's match, you can add or subtract them if their opposites are the same. Okay. If none of the numbers match, start multiplying one or both of the equations to make them match, and then you can add or subtract those equations together. Be careful of your signs though.